This lesson, we're going to learn about the kite. So a kite has two pairs of congruent adjacent sides. So it's a quadrilateral with two pairs of congruent adjacent consecutive sides. So that would look something like this. So we have a situation where these two sides are consecutive or adjacent, and those are congruent, and then these two sides down here would be congruent. So that's a kite. So there are several properties for a kite. So the first one is the fact that the diagonals are perpendicular, so you have all four right angles here. The, the other properties here, these other four properties, really are the easiest way to see them is if you think of the line of symmetry for a kite. So if you think about a line of symmetry for the kite, it would be this line right here at BD, so that diagonal would be a line of symmetry, meaning if I were to reflect over that line, you can see that this triangle on the left would map onto this triangle on the right. And angle A would have to then be congruent to angle C. So that pair of opposite angles will always be congruent. And that's one of our properties. And then same idea here, if I again reflect over this line of symmetry or over this diagonal that is the line of symmetry, you can see that AB would map onto CB, AD would map onto DC, keeping those sides congruent. So when we say that a kite has at least one diagonal forming two congruent triangles, we can see which two triangles are the congruent ones, the ones that would map onto each other using rigid motions. And then looking at these other two properties, a kite has at least one diagonal that bisects the pair of opposite angles. Again, looking at that line symmetry, imagine reflecting this triangle on the left over that line of symmetry to get the triangle on the right. And you can see that these two angles would map onto each other, as well as angle ADB would map onto angle CDB. So those are the angles that have to be congruent. So it's the line of symmetry that's really bisecting that pair of opposite angles. And then again, keep in mind, these angles that are congruent here, um, those are the angles that are getting bisected, that pair of opposite angles, and then the other pair of opposite angles are the congruent ones. So really think about that line of symmetry, because that can help you figure out, okay, well, which are the angles that are being bisected versus which are the opposite angles that are congruent. And then this last piece here is a kite has at least one diagonal that bisects the other. So again, looking at that line of symmetry, so the diagonal that's the line of symmetry, if you imagine reflecting over that, you can see that A to whatever this intersection point is would map onto C to that intersection point, meaning those are the congruent parts, meaning that short diagonal is the diagonal that's being bisected. It's all because of that symmetry and those reflections being rigid motions. So keep that in mind. That's the easiest way to remember the different properties for a kite. So let's go ahead and use these properties and solve one of these algebraic examples. So what we want to do is we want to find all the lengths of the sides of the kite. So right away when I look at this picture, since it's a kite, I know that the adjacent sides are congruent, or two pairs of adjacent sides are congruent. So those two sides and these two sides. They didn't have to tell me that this was a right angle, but because it's a kite, I know that the diagonals are perpendicular to each other. And again, looking at that line of symmetry, this line of symmetry is dividing this into two congruent triangles, which means the 12 and the 12 will always be the case here because that's the diagonal that's getting bisected. The picture already shows it, but just kind of reminding you of the properties. So right away, I see several right triangles. So if I look at this right triangle here, which is congruent to this right triangle over here, if I can find, let's say, X, that'll be good. That'll give me these two sides. And then I could use this right triangle right here to find this other missing side. So I'll call that Y. So it's basically, we're just going to be using Pythagorean theorem here to find our unknown values. So for X, I'm going to do, I'm just going to write out Pythagorean theorem first. So A squared plus B squared equals C squared. So I have 12 squared plus 12 squared equals X squared. So I have 144 plus 144 So 288 equals x squared. Square root both sides. And again, I'm going to break this down into simplest radical form. So basically, I have two groups of 144, or two groups of 12 squared. So that means my largest perfect square is going to be 144. 144 times 2 is how I'm going to get that. So this is going to give me 12 root 2. So that's going to be side xy is going to be 12 root 2. And the other side zy will be 12 root 2. So there's two sides. So now what I want to do is look at finding y. So I'm going to use Pythagorean theorem for this. So 12 squared plus 20 squared equals y squared. So I have 144 plus 400 equals y squared. So we have 544 equals y squared. And then we're going to look for our biggest perfect square that goes into 544. So 16 is the biggest perfect square. So 16 times 34 will give me 544. So square root of 16 will be 4. So 4 root 34 for y. So that means the other two sides here will be wx will be 4 root 34. And wz will also be 4 root 34. So there you have it, the kite example, or the kite with all of its properties, and then here's just using it. So go ahead, get some key ideas written down for the kite, and then try some of the check your understanding problems.